Alright, time for another math easy solution. We're going to discuss natural logarithms and log base 10 and do some examples. Well, basically, I showed my previous video what logs are and how, like, basically the inverse of the functions. And now I'm going to look at some the most used logs. So we'll go if we have f(x) equals e to the x, or let's go y equals this. So basically, if we take the inverse of this one's used the most. E, it has some special properties. See my other video on that. So basically, if you take the inverse of it, so you'll switch we'll go x equals e to the y. And then basically, if you take the inverse, see my other video on inverse, is basically where you define the logs. So then you're going to get y equals to log base e x. So this is basically natural log. That's a natural log. And since it's used throughout math, they just natural logarithm or whatnot. They just defined this one, log base e. They just wrote it like this, ln x. So this is the same. Yeah, so this is the same stuff. And also log base 10 is used a lot. So if you have log base 10 or x equals y, this correlates to basically x equals 10 to the y. And this one's used a lot. So in most textbooks and whatnot, let's say log x, it equals to log. It just assumes you're talking about log base 10 x. So this is the same stuff. Okay, so now let's actually look at some examples. Well, before that, there's another property we should write down. So basically, log base a times a. This just equals 1 because again, if you look at the definition, you'll have this. What this is saying is that basically a equals to, well, base a to the power of 1. Yeah, so that's basically, yeah. So then that's all this is saying, because if you look at the definition, well, x, yeah. So we'll have it's basically a equals to base and then whatever this is. So for example, then if you have ln, so if you have ln e, this just equals to 1 because this is base e. So that's all it is. So that's another property. Okay, so now let's look at some examples. Well, using the rules I showed in the previous video, let's try to evaluate this. Log 2 to the 8 minus, let's go log 2 to the 5. So what does this equal? So basically, if you saw my other video, I showed that basically log ay minus log ax, this just equals to basically log ay divided by x. See my other video on the proof. So then here you'll just get log 280 over 5, and this equals to, what is that equal to? 1. That's 4. So this equals to, yes, this is 16. No, oops. So I mean log base 2 16. So this is 16. And then now we can go further simplify this. Yeah, because we can further simplify this because 16 basically equals to 2 to the 4. We go to the 2 because of the same base. Show you why. So we get 2 to the 4. And if you see my other, so another rule is if you have log a to the a, let's say r, this just equals to r. Yeah, that's it. That's just equals to r times 1. Or yeah, this just becomes 1. So all you do is bring it down, and this cancels. So you'll just be left with 4. So that's the answer. You see my other video on the proof of this. Okay, so that's one example. Let's look at another example. Well, this one's an easy one. Let's just say find x for ln x equals 5. This is an easy one. So if you look at the definition again, basically you'll get x equals to, well, it's base e, so e to the 5. Well, this is an easy one. It's just using the straight definition of logs and ln. Okay, so we got that. Yeah, so well, this one's actually using the definition. What you could also do is just basically just go e to the power of both sides. So you go e to the power of that equals e to the 5. And then see my other rule, this just cancels, so you'll just left with x, because you'll have, as my other one is if you have a, I showed in my other video, if you have a to the power of log a x, this just equals x. So yeah, that's one proof you could get. So you could do that way. I'll show you my other video. I showed it the proof, the previous one. So now let's look at another example, a harder one. And let's go with e to the 5 minus 3x equals 10. So now what you could do here is actually, so this is basically how to get these. This one, what you would do is ln both sides. Ln, because it's base e, we want to get rid of this, both sides, and apply the rules I had before. So if you ln both sides, you'll get ln e to the 5 minus 3x equals ln 10. And then from, well, I showed this one too, if you have basically the same, if you have the same here, this just goes down. So log a, so you see the proof for previous video. So then this goes down. So this basically will become 5 minus 3x equals to ln 10. And then basically solving for x, you'll just shift this over. So we'll get, well, you could just take, let's say this goes there, we'll have 5, bring this here. 5 minus ln 10 equals to 3x. So I just moved this there and this there just because it was negative. And then so basically x equals 2. This equals 2. Let's write this 1 over 3. 5 minus ln 10. Yeah, let's do one more example actually. Let's go with, let's say if we have ln a plus 1 over 2 times ln b, and we want to write it as 1. Let's say write as just one logarithm. So basically what we do is use our rules before. Well, we want to put this, we want the same kind of so ln, we just want these look the same, so we'll put this on top with the other rule we got. So we'll get ln a plus basically ln b. This is 1/2. Because you could do this one. You can see this. I also showed it here. Basically, put it down. If you have the r there, this just goes down. So what I mean is, if you have something like, so another rule is if you have, let's say, a times log base b of x, this just equals to, well, this just goes on top. And I show again the proof of it in my previous video, so you get up there. So that's all we do here. Now we're going to do is the multiplication rule, or addition rule. So this one's going to be ln a times b. So we put those into one log. So it's very simple. Once you understand the rules, you can apply them to a lot. You could simplify a lot of stuff. Well, that's all for today. Thanks for watching. This is how to, that's basically what natural log is. It's basically log base e and used a lot. And also just to know log 10, log usually in most textbooks, it just means this. So on your calculator, sometimes it just be the same. So thanks for watching, and stay tuned for another math easy solution.